Hello, Flat Earth researchers, debaters and debunkers. I'm going fishing for clues to see whether we find any proof we live on a globe or indeed a flat Earth. And what we're going to do is something very simple that anyone can try out anywhere. And just looking at any body of water anywhere on the Earth proves that we can't be living on a globe. Yeah. You often hear the argument of gravity being a container for the water and the air on a globe, but that still doesn't fit with the narrative that gravity decreases the further away from this Earth you get, or from the center of the Earth you get. So this also, what we're going to look at is going to debunk the theory, or show that in reality doesn't fit with the theory that gravity is a pull on masses on the surface or above the surface towards the center of a spherical Earth. And this can be done by anyone. Let's just see how you're doing in the chat there. We've got Orwellian Rebellion. Hello, peace from Sweden, peace from Phuket. All right, sweet. Yeah. So think about this. Yeah, think about it first. You know what we're told to assume, and also the definition of level. Now, we all know that in the real world, level means horizontal, and that could be described as perpendicular to your vertical. Okay, as your vertical, your horizontal is 90 degrees or perpendicular to your vertical. Now, of course, you can then assume a globe model that your vertical goes all the way down to an assumed center of an assumed spherical Earth, or just which can be drawn out as a circle, right, with a radius of a certain distance to the center of that sphere. Having a radius of a certain distance and working with pi or whatever, dividing it up, allows you to have distances modeled, distances across the surface in terms of what would you call it, an arc distance. Yeah, so the arc distance, the distance across this part of a surface of a sphere, can be related to or converted into degrees based on an assumed distance of the radius to the center of your imagined circle of any particular scale. Yeah, whether you are good or not at mathematics makes absolutely no difference whatsoever. It's all about ratios, and actually the globe makes it a lot easier for these so-called mathematicians and scientists to create a model, because you don't have any bends, all the distances are equal, equidistant wherever you are. So then you can talk about level being the horizontal to the vertical, that is any particular distance from the center of the circle or the sphere that you're imagining geometrically, right? So you can imagine level being on one point on a curved surface, and still, or maybe you could be, let's say, a mile above the surface, your curved globe surface. You're a mile above it over here, and you move whatever 1,000 miles, and you're maintaining the same distance from the assumed center, and therefore you can say that you have remained but of course that isn't the level of the real world, and the level we see water doing. Hi, Execrate. Okay, hello, Blood. Good to see you, John. Zeus Scott. You do like to be beside the seaside. Oh, nice one. Okay. Well, good to see you all. Hope you're having a fantastic weekend. John Thor, hello. It's snowing. You're snowing. It's snowing with you. All right. Well, you can see I'm probably I'm sweating away there. So it's very hot and humid here. So right. Let's go. I'll tell you what I'll do. Maybe the best thing to do here is turn around the camera. Give me a second. and I shall reveal, tan tan tan. Okay, this is a nice little swimming pool that we've, even though we're close to the sea, it's a bit, it's nice to have a little swimming pool here, so it's for the kids to play around in, really. So here we have our body of water, right? Okay, complete with unicorn and plastic balls and everything. All right, and what you'll see is that we're on a sloped surface, yeah? Okay, I'll try and, if I kind of hold the camera somewhat level, you can see that this is actually, you know, a slope. So it's kind of, the garden is sloped there, going down. All right. So what we have is a body of water contained in this swimming pool. And we know, of course, that you know, it's a bit murky because the kids have been in and out of it all day, you know, running around in the grass. But we know that as this is on a slope, that this side here, the height of the water here in this body of contained water will be different to this height here. It will maintain its level, and that is indeed how we'll know it's on a slope, isn't it? So what I'm going to do, I'm going to use this little rod here. I'm going to go and get a pen, just a second. Use a black one. I think it still works. Black marker pen here. All right. So I should have brought someone to hold the camera for me, but we can do this. Hang on a second. All right. So this, just going to use it to measure. All right. So we'll stick it in down here. All right. And I'll put my finger on it. Okay. So it's there. All right. Okay. Fingers there. All right. All right. Okay. It's level with that wood. Hang on a sec. Okay. Level with the wood there. All right. Hang on. All righty. That's our first mark. Okay. That's where the water level was on the right hand side. Okay. What we'll do is we'll stick it in here on the other side now, okay? And this end is kind of more down the slope, right? So as you can see, we got, yeah, water here. The top of the surface of the water is higher than the one over there, okay? All right, so we've got to, oh, thank you, Abby. I'll leave that, all right? So come back, give me a sec to hold this and mark it. Okay, we've got this difference in the water levels approximately like this, okay? Understood? Yeah? Lower level over there, higher level over there. Because, of course, we know that water it maintains, so we know that our horizontal reference, our reference for horizontal is the water, nothing else. It's contained now. And, of course, you know, we need this rigid container. And you know that if you let the water out, if you let one side of the container down, then, you know, what will be the physically higher level on this side will, of course, pour out. Yeah. So, you know, this can be any size, right? This can be, you can scale this up as large as you want. The physical properties of the body of water, which is now, this is a mass, isn't it, Abby? Yeah. All right. This body of water is a mass, yeah? Okay, it is a big lump. So think about what they say about the globe Earth theory for gravity, yeah? What they tell you, if you imagine that this is, these sides, okay, the sides of this swimming pool are a vast ocean, and it's the cliffs of countries either side, okay? Yeah, and so of course, in the real world, we have sea level. There is this level, which is the same distance between each location. Yeah. Okay. But if we were on a globe, then water wouldn't behave like this. It just wouldn't do this. The idea is that you have a body of water here now, and that's being acted on by gravity based on this body of water's volume, its overall density, okay? So really gravity should be acting on this, and if it was on the globe model, if this was a vast ocean between continents or countries, whatever, the idea is that this body of water would have this convexity that would actually keep the water level at the same level on each side. That doesn't happen though, does it? Yeah. Okay. The only way you can have that is on a level Earth. You can't have, based on the physical properties of the water that we see here, then this doesn't work on the idea of a globe Earth. So you have, this body of water. If we were on a globe, this body of water should have the same level on either side. Okay, we should have the same height measurement of water from the bottom to the top on the right hand side here, and from the bottom to the top on the left hand side here. Okay, that's how it should be, given the theoretical physics of gravity. It should be pulling on this one body of water, this sole mass of water, equally towards the center of the assumed sphere. Do you understand? So if we were living on a globe, this swimming pool of water would have water at the same depth on each side. Okay, it wouldn't matter. It wouldn't matter the size of your container. Okay, it could be a meter, it could be 1,000 meters, it could be 10,000 meters. Yeah, it could be 10,000 miles. Yeah, you understand? The physics would be always the same. Once you contained that water, yeah, whatever size your body of water, okay, the gravity, the globe Earth gravity should be acting on it equally. That's the whole idea of the model, isn't it? The whole idea of the model is that it has this equal pull wherever you are. So there should be equal pull, creating the same depth of water. But we've just seen here that we do not get the same depth of water. Yeah, this side is shallow. Okay, there's our marker. All right, that's the first marker on the bottom there, level with the water. Okay, put it on this side. All right, I maybe misplaced the marker there, but basically you can see that the water level is higher than the marker when it was over there. Okay, all right, and that's it. That's simple proof. Yeah, anyone can do this and think and apply reality, real life, to the model, and you realize that it is just a model. It's just a concept. Okay, so let me just turn this around again. Yeah, it's as simple as that, isn't it? Yeah, right then, let's just go back through the chat. Okay, it must be curved. Yeah, you were saying it must be curved, right? Yeah, how can it bend? Zoo Scott, how can it bend when collapsing into itself? Yeah, uncommon sense. Hi. Cellular Earth reality. Oh, hello, cat. All right. Careful. All right. Yeah. All right. Thanks. Oh, I'm getting a bit hot and sticky now. Hello. Cellular Earth reality, the usual thing, still lacking. Of course, no one's got a proper map, because the whole point is we don't know. You've been told this before. So, if you demand maps and models as alternatives to the one that's just been debunked, then you're living in your own little dream world. That's all the attention you're getting from me today. What's that? Gattaca, the sea eagle. Did I say that right? Gattaca or the Gattaca? Maybe you have to be a unicorn to see the curve. There you go. The unicorn can see the curve, yeah. Human Walker, hello. Oh, Harmon Walker, hi. 1 in the morning, wherever you are, okay. That's because you're on the other side of a globe. Yeah. It's funny, isn't it? This is the thing. You have to. All we're doing here is, and I have found, I must admit, that what you do find with if you are a truth seeker, and flat Earth being one of the many truths that you've come across, and you're maybe labeled as a conspiracy theorist. The thing is, you are one of the few people among an unfortunate majority that really don't think in the same way. A lot of them, you see, there's you'll remember asking yourselves those questions, not being satisfied with the answers. I remember thinking about infinity and really not being satisfied with the answers. I remember thinking about whether I could have a teaspoon of water and that would somehow make its way around the world and come back and be the same teaspoon of water at some other time and place. Things like that, and the origins of water. This is it. We have certain scientific explanations or things that astronomers have come up with, ideas and stuff, but no real solid answers to those questions. The really fundamental ones. Where does all of this stuff come from? Where does the water come from? Where does the fresh water come from? Now the thing is, when you start asking questions like that, you know that you're not going to really get any real answers, and there seems to be this cutoff point in a lot of people's minds where I suppose ultimately you can all understand that there's almost no point in asking the how, why or where of everything, because it is almost impossible to tell. But that shouldn't prevent us from trying to find the answers. That's the thing, isn't it? That's the difference. You're looking for the answers. You're not satisfied with, okay, so where does the salt water come from? Where does the fresh water come from? And I must, a good friend of mine in Portishead brought this up. We brought up a couple of things, really. But there was the kind of, what came first? Was it mapping the stars and navigation, or chronology, keeping time? And obviously, we understand that they are both, they intertwine. But the other thing that we talked about was crystals. Now, this guy Leon was kind of, he raised the subject of, the huge amount of crystals that are under the earth, and maybe crystals growing is what creates things like earthquakes, and all you need for a crystal to grow is water. Often you do it in school, right? You hark back to those school experiments where you're putting a string into some saline water, some salt water, and the crystals start to grow on the string, right? So, this is what we have in terms of the sea. We have saline water, or water that's full of all sorts of minerals and things like that. So, is the sand on the seabed and on the beaches not necessarily rocks that have been ground up and crushed by the waves and stuff? Because the sand goes forever. But what if the sand is particles that have been formed out of the elements in the water? Yeah, just as you can create salt from water, everything's soluble in the water, right? Everything's dissolved, I suppose, in the water. So over a process of heat and other things that go on, environmental situations, then you've got I suppose crystals forming. And so I suppose the question is sand, do not put that cat in the you're just about to put the cat in the pool. No. Oh dear. It looked like you were going to, and then he would never be your friend again then, and he would puncture the pool as well with the claws. Yeah.
No, I was actually not going to put him in the pool. I was just joking.
I know, but but you'll end up getting hurt, okay? Cats really don't like water. Well, some do, but I don't know about ours. Yeah. Anyway, don't risk it.
But whenever he just touches a little bit of water, he just
really shakes it off. Yeah. Okay. Yeah. So yeah, is sand actually crystals and particles that have been formed from the elements that are floating around in the water, and they are congealing and coming together and falling to the bottom? So this whole idea of a crystalline Earth makes a lot of sense, actually, if you imagine, and this is where a lot of the sand comes from, a lot of the movement. Crystals grow, and all they need is water, and that's what we have an abundance of. It's a fantastic theory to think about, and makes a lot more sense than seeing sand somewhere that is different to the land that it touches, of its coastline, and then and so where did that all come from? Well, of course, if you look at sand, it's made up of all these diverse things. It's not one particular thing, is it? Yeah. So yeah, maybe like oil is assumed or is said to be an abundant source that's just being constantly created by the earth. Maybe the sand and the water is as well. You've got this nutrient, mineral-rich salt water that could in fact be creating the land. Okay, maybe the land is kind of these basically crystalline formulations, right? Okay, or that's the foundation, and then of course you've got dust and dirt and layers of this and that on top, and something that could have been going on for billions and billions, or for eternity, for so long that we wouldn't know, with maybe catastrophic events. You see, you don't even need to, we've always got this the singular assumption, because of the globe model, that any global catastrophe is the result of something colliding with the earth from space. But it makes perfect sense that the surface is changing because of things that are happening underneath, and we don't know what's really underneath. We don't know more than 9 miles down, do we? So yeah, how's that sounding in there with the chat? Well, blood's thicker. What you're saying there, the surface of large bodies of water at rest form a horizontal plane of reference. Exactly. Yes, blood. That's it, isn't it? And that's the thing, isn't it? All you got to do is look at the physics of water, look at reality, and it tells you that the globe, it just debunks the globe. Reality debunks the whole globe theory. Yeah, that's it. Yeah, that's really succinctly put. Yes, I agree. Nice one. Nicely said there as well, Zoo Scott. One man and his detector. Hello. Could it be they are called continents because they are containers for water? Ah, nicely put. Yes. Interesting. I suppose the oceans all do eventually interact with each other, don't they? They do kind of flow. But again, we don't know. That's the thing, isn't it? We don't really know the extent of the containment. Yeah. And the fact that what do you have? They have these dome, these kind of, you can get those tropical forests in a dome. What are they called? Bavariums, or I can't remember what they're called. Vivariums. I can't remember, but you can, like an air aquarium, and you have this enclosed system that the water goes around and around, the fresh water. Of course, you can introduce things from the outside, but basically everything lives in harmony within this enclosed system. So, again, it's as far as models go, this is something we can recreate. We can also recreate levitation if you assume that the sun and the moon, if it is a body, you can assume that those bodies up there are held up in the sky through some form of frequency, levitation, magnetic or otherwise. Well, we can do that. We can actually make that happen in various ways, with sound, with frequencies. There's a real science to that. There is no science to this mathematical idea that water will stick to a curved surface, and it's, as I said, we've just proven that it doesn't do that in our reality. Yeah. Okay. Harmon Walker, it's so nice to seeing you smiling. Oh, thank you very much. Okay. Yeah, it's nice to be at home with the children. I don't want to spend too much time doing this, and this is why I've been quite absent for a while. Lots going on work-wise, which is good, So, and with the kids, they've got lots going on in their lives as well. So, obviously, any parent would try and focus on that. Trip to UK was nice, but yeah, back to kind of nose to the grindstone. Blood's thicker, it's not flat. Surveyors measure changes in elevation for a living. Exactly. Yeah, okay. Hello, Peter Fallows. Hello there. Okay, one man. Harmon. Oh, you're right outside of Las Vegas, USA. So you were saying it's cold. So it's cold in kind of around the LA area, is it now? Okay. Right. People and their models. Links 88. Hello from Spain. Hello there. Zoo Scott. She's a model and she's looking good. Okay. Harmon Walker. I've been in this since 2017, and my family is still not communicating with me, and even worse since the jabs. Yeah, it's a shame. Yeah. Well, I think we all kind of we get to that point. We've probably all been through it, right? Where lost the connection there. I hope one of these relatively few people that is on this truth-seeking journey. A large part of that is being open-minded. You're open to learning. You want to learn more, and of course, it goes way beyond the academic education we get, and the social interactions, everything, the experience, and often you have to push yourself into uncomfortable situations because you want to progress. You want to, and so there is definitely. You have to approach this with an open mind, which unfortunately a lot of people don't have, and they don't know that they have a closed mind. They're, again, it's about this different. We're having problems connecting. Okay, we're going to leave this now, and we'll talk about that's another topic. Close to the house, but we're having trouble, so I'm going to leave it there. Okay, and thanks for coming along. Oh, hi Al, by the way, and this obviously if the connector's not good, then it's not worth carrying on. So, all right, gonna catch up later. Okay, but there is our flat Earth level water proof. Okay, right there in your sink, in your bath, anywhere. Okay, and just shows us what reality is compared to the models. Okay, so have yourselves a good weekend. We'll catch up later. I want to do something more on this esoterical stuff, the nature of consciousness and awareness, and what that really is, and how it helps us in this very unconscious world a lot of the time. So I'll bid you farewell for now, and we'll catch up soon. Okay, cheers.